Okay, it's a light crowd tonight, but maybe it's the rain that kept everyone out. Looks like we got a few more people coming in. What I'd like to do tonight, I took a look at the practice tests that I've handed out to you. Again, this was made up by another professor. The test was made up by a different professor, but this was made by a professor who saw the test and made this up, some questions for us, open-ended. I looked at the test just before class time, and these have all the types of problems that are on the test. There was nothing on the test that isn't on here. Okay, there's 25 questions, but they're all similar to this. The difference is the test itself is multiple choice. So not only will you have the questions, but you'll have the answer and 3 wrong answers. So you just got to choose the right one. So it'll be a little different because you can sometimes work backwards if you want to see which one of the answers are right. So there's maybe a little different strategies, but if anything, it should be easier because you'll know what the answer is supposed to look like because you just have to choose the right one. Okay, so we'll have a Scantron form. You'll just be choosing A, B, C, or D, bubbling it in, and that's how we go. Okay, you don't have to show your work, but you can show your work, and I can, which sometimes helpful if you got a question wrong, you bubbled in the wrong choice, but you got some good work, we can go back and take a look at that and get some either partial and sometimes even full credit. But it's not required. You don't have to show your work when you do it. So what I thought is, since there's 24 questions, we probably have enough time to do them all. I would just start at the beginning. We'll work through them. Your jobs is if you have questions that you ask them so that, because this will be recorded, you can go back and look at it later. But that's the videos, you usually don't ever get the chance to ask a question of the video. And if the person explaining it missed what you wanted to have explained, then you're kind of out of it. So this is your opportunity to talk to the video. I was thinking I would make it by myself, but I thought let's just make it during class time, and then this will be the live stream. Will be there for you to take a look at.
And then we can see it at home too.
Yes, right.
So then basically we just go through every one of the questions then, so that then it's just going to be what we have to look at on Monday as well, right?
Yes.
Okay, perfect.
Unless you want to skip some, you guys are kind of in charge. But if you wanted to skip one, but it's probably because it'd be so easy. Yeah.
Straight through it, and then that way it's all there because you don't know who might not be here tonight.
Exactly.
Might have a question about it.
Very good. So now I've got my live stream going. This morning I was my earlier class. I forgot to start the live stream. I had everything going except I didn't click the button.
And then the word wasn't there, right? The word of the quiz.
The word of the day.
Wasn't there?
Well, no, because I didn't have anything. So, but
Last week I was looking at it.
On Monday you had a word of the day.
Well, on Monday, but for today's class,
No, but for Monday I didn't find it.
Monday?
Tony the Tiger. It was great.
I might not have put the quiz up though. You're right. I may not have put the quiz up.
I didn't even look. I
Okay.
started looking and
I'll
had a lot going on.
Okay. I'll look for it.
But we got to pick one for today.
rainy day.
I know, yeah, rain. Today was great. Yeah, for the last one. The last one. Not today.
Yes. You said rain.
Rain sounds like a good word of the day. Okay.
Rainstorm. That's clever. Oh, rain. Yeah, rain. Okay, rain.
Click here. We'll start at the beginning instead of starting at 19.
Valentine rain.
Yeah.
Less than or equal to or greater than or equal to.
Okay. We ready? Okay, yes.
Okay, so
Open circle
open
is
circle is for less than.
less
greater
than, or is that parentheses?
Okay, this one is,
It's,
So the open one?
this one?
Open circle, closed circle,
It's for
closed
less
is
than and
infinitive?
greater than.
closed is included.
Closed is included.
yeah.
That's what I was trying to.
We'll talk about that. We've got some inequalities where we'll do both of those.
Okay.
So,
Or greater than the 40%.
all right. So we'll just start. We'll just go step by step. And I think we might be done with this in 45 minutes. Whatever it takes, we'll do it. And then you'll have the rest of the class time to continue working on your own because, again, but this, remember, will be available to you to come back and review. We do not have class on Monday. It's President's Day. And then we will have the test on Wednesday evening. Okay. So the first one, let's see, where are we? Is the question, it's a word question. We look for maybe numbers first. So I see something with 4 seconds and less. So you run a race in 4 seconds less time than it takes your brother to run the race. And we're going to write an algebraic expression, not an equation, so this is no equals, just an expression to represent your brother's time in terms of your time, x. So who is x?
You.
You. So x is your speed. Who's faster, you or your brother?
Brother.
You run a race in 4 seconds less time. It took you 4 seconds less than your brother. Who finished first?
Oh.
You are
Oh,
faster. You finished first, yes.
Okay.
So you are faster than your brother. So you finished, so to get to your brother's time, let's say you were 10 seconds, what is your brother's time?
6.
Or 12.
Oh, 12.
14.
Okay.
He took, you got to think of this from his perspective. He is 4 seconds slower. He took 4 seconds longer.
Oh, okay.
So we have to, whatever your time is, we have to add 4 seconds to it.
We got it right. I just did it.
Okay.
yeah.
Yeah.
Okay.
So this is, I just did one of this in my 081, and it's an
Yeah.
easy one to switch it because you start reading it and you think, yeah, the brother's faster because he did it in less time. But no,
So
you,
X is the brother?
no, X is you
It's me.
in terms of your time, X. Okay, so there's a lot of wording in here that can throw you off.
Yeah.
Okay, so X is your time. But we want your brother's, so this is your brother's time. If anything, you could label it as brother's time. Okay. And that's the expression. And again, on the test, this question would have been there, and there would have been 4 choices. And x minus 4 would have been there, as well as x plus 4, plus some other things, maybe 4x or something. But that's what's going to get you is the wrong answers will be there that might seem like they make sense. Okay, so far so good. Okay, number 2. Now you might say, okay, we got to distribute this 3, but the question's asking to just write the story of x. Okay, write the story of x. We don't need to solve this. We don't need to simplify it. We just need to write the story of x. So we start with x and we say what's happening to x first.
Multiply on 2.
X is multiplied by 2. And again, remember, so it'll do step by step, and this will be multiple choice as well. So you just have to walk, the steps will all be there. So you don't have to worry about whether you're phrasing it correctly. You're just going to choose the right one. So the first thing I have is multiplied by 2. What's the second step?
Add 1.
1 is added, or add 1. And I always like to put 2 result. Then what's done?
Multiply by 3.
Then multiply by 3. So it's just really getting the order that the operations will be done in.
Because you're telling the whole story.
Right. And from the perspective of x. So we always start with x and we work inside out. Not a problem. Okay, so there's one like this. And that's a two-stepper, so it's not even as complicated as this, but it just tells the story of x and you got to choose the right one. And again, it'll give you some wrong directions. You just have to be able to choose the right one. So again, for every right answer, there's 3 wrong answers. Usually 2 really obvious wrong answers, but 1 really good wrong answer. There's always 1 really good wrong answer. And that's the one that you get thinking that you need to choose. Okay. Write an algebraic expression from the story below. So we do both. We ask you to tell the story, and then we give you a story and ask you to write it out. So you'll see both of these. So step 1, subtract x from 4.
So if I did 4 minus x, would that be okay?
That is not only okay, it's the only correct way. It's not x minus 4. Subtract x from 4. In mathematics, that means that the 4 is first, and we're subtracting the x from it. So subtract from. We've got to switch the order. It's a tricky wording. Then what do we do?
Divide by 7.
Do we divide the 4 or do we divide the x? The whole thing, right? Because each time in our story something was completed. So we're going to divide by 7. This would be the right answer we're looking for. And again, on the test, you'll get, this will be on there if this was the question, but you'd probably also see x minus 4, which would be wrong, over 7. Yes?
Could you put it like 4 minus x in parentheses and then just like divide by 7?
You could.
Do the same thing.
Yeah, you could do this.
But there'll only be 1 right.
But there'll only be 1 right. And again, they could do the same thing. The nice thing is you don't have to worry about it. It'll be either one of these, but not both of them. And they're not going to give you one notation that's right and one that they didn't ask for. These would both be correct ways of following the story.
How about without the parentheses?
Without the parentheses, no, because then what would happen is the x would get divided by 7 first,
Oh, right.
and then you would subtract the result from 4. So it's changed the order. The story's been changed.
PEMDAS, right?
PEMDAS, yes.
And then
So
you write
that's,
it either way.
yeah,
And that's right.
yeah. Both of these are correct.
Yeah, without the parentheses, change everything.
But without the parentheses, you've changed the order that things would be done in.
Well, because you have to divide
You have to divide first.
before you multiply.
Right. Exactly. So far, so good? Feeling good? Okay, and again, as we go through this, what I want you to do is, with the exception that you will also see multiple choice answers, when you come in, you'll be looking at very similar questions to these. And you have really a whole nother week to prepare yourself. And remember, this is being recorded. If you run into some questions that you're still troubling and you want to see some additional ones, you can find those in the practice problems. You can find them in the homework problems. And if you want me to make some mini videos, I'd be happy to do that.
I actually wrote the numbers of the pages where I found.
Very
them
good.
So I could refer back. So
That's a good thing to do. Exactly. Okay, so number 4. We've got a statement. The truck can hold at most 2,000 pounds of weight. Okay, this word, at most 2,000 pounds of weight. Write an inequality using the variable w to represent the weight of the truck can hold. We talked about this. So the truck can hold, so the weight of the truck can hold is w. You can hold that weight. At most 2,000 pounds. So there's a relationship between w and 2,000. Which one is bigger?
2,000.
The 2,000 is the most. It can't be any bigger than that. It actually should be less, otherwise you're going to break an axle, right? So the w has to be smaller than the 2,000 or equal to, right? At most means less than or equal to. Okay. Means it could be 2000, but nothing more, not 2001.
If you flipped it, but you had the sign going the other way, that still would be okay, 2000 greater than or equal to W.
That would be okay as well. Yes.
I always get confused, why do you put the
Either
line
way.
under the less than?
It could go negative, but.
That says that it can be equal to.
Okay.
And because this word we were given was at most 2000 and not just less than, at most implies that it could also be equal. Okay, so that's where you get the, yeah. So that's the equal to part, the underline here. And incidentally, we were talking earlier, if we were going to do an interval notation on this with a dot, with brackets, if we were going to plot this, so on a number line, here's 2000, and that the weight that the truck can hold would be a solid dot, because it can be 2000, and then we shade this way. Now, infinity, negative infinity really doesn't make much sense here. You go down to 0 pounds, it's not holding anything. So we could write this as it could be holding 0 pounds all the way to 2,000 pounds if we use any interval notation, okay, with brackets. Okay, solid dot, brackets, because of the equal to. So again, the solid dot also comes from this little line here that we're equal to. And we'll have an example that doesn't have the line that is not equal to, and we'll see that's the open dot, that's the parentheses. Okay, so I know there's kind of a lot of things. And again, remember, everything in math, somebody made it up because it made sense to them. Doesn't mean it makes sense to us. We might have wanted to do it differently. Or we might not have wanted to do it at all. I mean, how many of you go into math class because you wanted to go to math class? It's in your program, so you're taking it, right? If it wasn't in your program, just not going to get me a job, right? It might be valuable to you, but yeah. Okay, so far so good? Okay. In the expression, so we're given this expression, but again, we're not asked to do anything with it necessarily, but except to identify what is the coefficient and which is the constant term. So we have to know what is a coefficient.
The number with a letter sign?
The number with what?
With a letter sign?
With, yeah, so the number in front of the letter. So we find the letter, the number in front, that's going to be a coefficient. That's all a coefficient is. It's a number in front of the letter. So the coefficient will be 0.5. What's a constant term? It doesn't have a variable, right? If you're constant, you don't vary. So there is no variable. The one without the variable is the 4. And since we are subtracting 4, but usually we'll list it as a -4 is what the constant term is. Okay. And again, there's one like this on the test, but it's a multiple choice thing. So there's you know, some that would say the coefficient's -4, the constant term's 0.5, and some other wrong answers and stuff. But so just be able to identify the right one. Okay. I think on this one we might need a little bit more room. So I'm going to, let's see, take a picture. Let me save it. Where's it going to save it at? Let me just put it on my desktop. Do page 1, and I'll figure it out later. So that's, oh, it's kind of messy up there. The word of the day is rain, for those who have come in a little bit late. So let's I'm going to highlight that again, just for taking attendance. Word of the day, and the weather of the day is rain. Okay. Unfortunately, I was tired this morning, so I didn't feel like riding my motorcycle, so I just rode the car because I was tired. Otherwise, I'd be riding home in this stuff. And
Lucky for you.
that's no fun.
That's okay.
Yes, very lucky. Okay, so Ray, so I'm gonna, this has been taken a picture of. Let's go for another, get a new page. Isn't that?
I just don't mind.
And I'm going to move 6 to the top, and we'll deal with this because I want to show you also an example of this one that's a little closer. What I meant was the practice test has all the problems, but it does also have a few variations, and I'll work those variations here so you won't be surprised. Okay. Let's go to green color. So write the algebraic expression to represent the item price P after being increased by an 8.5% sales tax. So we want to represent not just the sales tax, but sort of the total price we're going to pay for something. So when you pay for something, what you're paying is you're paying the full price. So that's 1P, or P, right that way. Plus you're going to pay the sales tax, and the way we get the sales tax is we take 8.5% times the price. And 8.5%, we write that as a decimal. How do we write that as a decimal?
0.085.
You can move the decimal over 2 places or divide it by 100. So you take 8.5 divided by 100, and that will turn it into the decimal 0.085. And take the time, because I'll see people who will do this in their head, and sometimes they'll write it as 0.85, which is at actually 85%. But it's because you maybe just went through it too quick, or something, or you might go 0.0085. You might move it too far. So whatever you need to do. Now, are these two like terms? Let's see, 0.0. That's supposed to be an 8, not a 3. These are like terms, aren't they? They're both P. So we can add them together. We can take 1 plus 0.85, and what we get is 1.085P.
That's an expression.
And that's the expression. That's it. So that's the total price. And think of it. It's 100% of the price plus 8.5% of the price. So it's 108.5% of what the price is marked. So when you're paying sales tax, you pay more than the price of the item. That's supposed to, the extra that we're paying is going to the state, or for whatever, to schools or some politicians' pockets. I don't know, but we become more and more cynical as we see more and more corruption, and we get more and more guaranteed that there is no corruption. I think there is more. The more they say there isn't any, I think the more we find out that there is.
Yes.
Okay. Now, for the same problem, what I want to do is I want to think, what if we had a discount, like they had a sale, a 30% off sale? How would we do that to come up with a
Subtract it from 100 to
Excellent, yes. So we would have, we were going to pay the full price, 100% of P, but we got a discount of 30%, which if you write as a decimal, it's just 0.3 or 0.30 if you want. And the discount is based on the price. And so the difference is it's really the same type of problem, but we're subtracting instead of adding. And so 1 minus 0.3, we end up with 0.7p. Okay, so I'm going to write over here, this is an example.
It could be like this in the test too?
Yeah.
Why is it
And
0.7?
what?
Why is it 0.7?
Take 1 minus 0.3.
Oh.
And because, right, a lot of times we don't think in decimals. And so it seems kind of strange, but you're taking, if you thought of it, it's 100% minus 30%. So if I take 1, oops, I gotta switch over to this thing. I could take 1 minus 0.3, and I get 0.7. Okay.
Or 100 minus 30.
Or 100 minus 30 is 70%, so as a decimal, that'd be 0.7. So far, so good? Yes, and the reason I give you this is because I've seen the promised land. I've seen the test. If I put something on here, it's not just because I want you to, it's not like your dad sitting down and said, oh, let's just try these extra problems. You have a dad that did that, taught you math and said, oh, just for fun, let's do these extra homework problems. I said, Dad, I just want to get my homework done, right?
It's 70? 0.70?
Well, yeah, you could write it as points. The last 0 isn't important, so it could be written as 0.70 or 0.70,
Okay.
but it
7.7p.
yeah, 0.7p is probably how it'll be written. And again, you just got to choose the right answer, one of these two. So it could be adding something, it could be subtracting something.
Can you go over that again?
Sure. So we've got an item we're going to pay a price for. We're going to pay its price. So usually we would pay 100%. Okay, and maybe I'll do it with a percentage, right? Whatever the price is, it's 100%. You could do this sort of separately too. If it's on sale for a 30% discount, what does that mean? It means we're going to take 30% off of the price. And this is actually how I calculate sales prices. I don't go for the discount because it doesn't matter what you're saving, it matters what you're paying, right? Mm-hmm. And you can find that discounts are always subtracting from 100. So 100 minus 30, again, an easier way to think of it for me, 100 minus 30, that's 70. When I do it with decimals, it doesn't seem right, but 70%. So I'm going to pay 70% of the price. And 70% of the price means to take 70% times the price. And when I do that, I always do it as a decimal. So I'm going to take 70%, I'm going to divide it by 100. That's going to give me 0.7. Where'd my calculator go? It's hiding. It's back there. And that's going to be times the price, whatever the price was. Right, so we could do it this way. 100% minus the discount of 30% gives us 70. 70% divided by 100 turns it into a decimal, which we can do math with, 0.7. Okay, so two different ways to think of it. You can think of it, taking the discount by the percentages first and then just multiply it. Or you can think of it as full price is P, 1p, subtract off the discount, which is 0.3p, and you end up with 0.7p.
Now, if you do that, then are you still going to add the sales tax?
Not in this problem.
Not in that one.
But yes, at the store you would, yes.
Right.
And
Yeah.
so then now we gotta, but we're not gonna do that to you. Yeah.
So,
Because the sales tax is now on the 70%. You don't pay sales tax on the original 100%. You only pay it on the final price. So, yeah, that's too much math. Good.
I understand P represents price, but
Mhm.
why do you put 1P in front of it to show that there's just one item and that's the full price?
Right.
Okay.
Because if we don't, then you think what's in front of the P. Some people think, oh, there's a 0 in front of the P, or it's just, but there really is always a number in front of the variable. And when 1's in front of it, what happens when we multiply by 1? Nothing. So that's why we can put it there. And in algebra, it is always, the 1 is always there because it's, sort of like the invisible thing. It doesn't really do anything. It's almost like the wind. A low wind doesn't really do much. You almost don't miss it. But when it gets too powerful, it happens, right? It's missing stuff. But it's just like the air. It's always here. And if we didn't have the air, we would all be passed out. But we don't think about it that much. We just take it for granted. In algebra, there's always that 1 there, and you've got to remember it's there. We need it. Yeah.
Who came up with that?
I don't know. But that was one of the things I did, is when I realized there's always an invisible 1 there, it really helped. Okay, so far so good? We're about 20 minutes into this, and okay. Let me just switch colors a little bit so we can break it up. Let's go with violet. Solve the equation. So this is where we're past the times where we're just kind of saying what equations have and expressions. We're actually now going to solve an equation. Okay. I did change it a little bit. I made mine big, make things bigger on the test. They're smaller, but I just thought I wanted to have room to work things. So we've got this equal sign. So we've got a left side and a right side. Yeah. So maybe even sometimes it's helpful to divide it up. What do you notice about this first equation? About the x's? How many x's do you see?
2.
And they're on separate sides of the equal sign. So when you've got this situation, this is the multi-step problem. What's the first thing we really want to do?
Get rid of 1x.
I like to think of it as getting the family together. But yes, we're going to get rid of 1x. We're going to bring the family home. So we've got a negative 3x and a positive x. Which one should we move? We're going to move them together. Which one?
3x.
Yeah, because if we add the 3x here, it becomes 0 on this side. Oops, 3x. But whatever we do to one side, we do to the other. Okay, good. So yes, we get this part to sort of just cancel off. The 4 comes down. The equal sign's still there in the middle. The 12 is not a like term to the 3x, so we take 3x plus, again, 1x. Remember that 1's there. If you don't, 3 plus 1 is 4. It's 4x. Now remember, we moved to the right. Now what are we going to do? Move everything back to the left. Okay, so it's this sort of this rhythm that goes, we move to the right, now we're going to start, because we want to get the x by itself. So the next thing we want to do to get x by itself, x is getting multiplied by 4, and then we're adding 12 to it, so what should we take care of first? The 12, because we're going to work backwards. So to get rid of a positive 12, we have to subtract a 12. So because it's opposite of division, or opposite of addition. So we minus 12 from that side, we minus 12 from this side, keeping things equal. So the 12 cancels out. The 4x just drops on down because it's still there. The plus sign is still sort of there because it's a positive 4. And then we've got 4 subtract 12. Signs are opposite, so we do subtraction. 12 minus 4 is 8. Is it going to be a positive, or it's a negative 8? Because the 12 is bigger and it's negative. We have one less step. And back to green. What do we do now? We divide, because we have to undo multiplication, so we divide both sides by 4. Divide both sides by 4. This side, 4 divided by 4 is 1, so there's our 1x. I'll just move it over here. And then negative 8 divided by 4.
2.
Negative 2. And again, that's the answer we'd be looking for. Now, just a little word to the wise: if you get stuck, you're going to see these answers: x equals negative 2, and actually it might be written like this: x equals negative 2. So, and that's the same thing. Could we have taken this negative 2 and plugged it in for x on both sides and checked it out? Yes, we could. So that's another way. If you get stuck on stuff in algebra class, a lot of times you can reverse engineer it, plug it in, see if it worked. Again, in some sense, that's a little harder because you might have to check 4 of them to get the right one. It might not work the first 3 times if you're just plugging, what we call plug and chug. But if you don't know what else to do, a lot of times it gets you the right answer.
I'm just curious, because this is where I can sometimes get myself confused. How did you know to take how'd you know to take negative 12 and 12? Why did you pick the 12? I know you made it a negative and that's a positive, so that makes it 0. Is that why?
Right. We're
Okay.
looking, in algebra, we're looking to make zeros and 1.
Okay.
And we do it because that's how it happened. We could add anything or subtract anything, but it's by making zeros and 1 that we simplify things.
That helps.
Good, yeah. Because it's always, I always wonder, why did you divide by 2? Well, because there's a 2 there, and I want to get rid of it. The way I get rid of a 2 is I divide by 2. Why did you subtract 12? Because there was a positive 12. If I subtract a 12, it'll make it go, it makes it into 0. And that's really the trick. Algebra is just making zeros and making ones. So it's actually, and it just seems too easy sometimes.
But you'd actually write it negative 2 equals x.
Right.
Not the other way around.
You can write it x equals negative 2. Again, that's the nice thing of an equal sign. It's ambidextrous. Left and right can just swap.
Okay.
Okay. Another solve the equation. We ready? This one has a fraction, but we don't care because we know it's not going to be that bad. Let's go with blue. Okay. So it's a little busy here, but we know what we're doing. Let's put a line here. So we've got, now do we have the issue of an x on both sides this time?
No.
No. So this is really just a two-step problem, right? We've got x, it's being multiplied by a half, and then we're subtracting 2. That's the story of x. Okay, so use the story. The reason we do the story of x is it's just a nice technique to think through a problem. And once we know the story of x, remember we work it backwards. So while we multiply first and then subtract, when we go to solve, we go backwards. So what do we want to do? We want to add 2. Why? Because it'll make it into 0. And then, once we know to do this, on the other side, we do exactly the same thing. Okay, negative 2 and positive 2, that's why I like to circle them. They become 0. And when something's 0 in algebra, it disappears. It just goes away. So it's 1/2, x comes down, this disappeared, 3 plus 2 gives us 5. Now what do? We got a fraction over there. Hate fractions, right?
Flip it.
Flip it. We multiply by its inverse. So 1/2, if we multiply, see, fractions are really, they're easy to get rid of. They really are. Just multiply by their inverse, 2/1. So I take the fraction, flip it. 2 divided by 2 is 1. 1 divided by 1 is 1. We just got rid of it just like that. Okay, that's the thing. When you see a fraction, flip it and multiply, it'll disappear. Easier than a annoying fly in your face, right? But if we do it on the one side, what do we have to do on the other side? The same thing. This is the thing is I wanted to emphasize is you have the power to do anything you want as long as you do it to both sides. So again, then here we're going to multiply by 2/1. But really, what is 2/1? It's just 2. So it might be easier on this side just to not call it a fraction anymore. Let's just call it 2. Okay, so it's really just, or if you want, you could put 5/1. 5 times 2 is 10. 1 times 1 is 1. 10 divided by 1 is just 10. So sometimes having the 1 is like, there's times when you just want to leave it behind. Okay. It was helpful when we were dealing with fractions, but on this side it's not necessary and it can just let it go away. Okay. So just like in life, sometimes if you got to cross a river, what's a good thing to cross a river in? A boat. But you get to the other side and now you got to hike the trail. Do you want to carry that boat with you? No, just leave it behind. It'll be there when you go back, right? So the boat was helpful in crossing a river, but it's not going to be helpful in crossing a mountain. So you leave it behind. And that's the same thing we do with the fraction. It was helpful on the left side to write 2 as a fraction, 2/1, and seeing the things cancel out. But on the other side, when we didn't have another fraction, it was actually just easier just to think of it as 2 times 5 is 10. Okay, and again, you'll just have a number here, and if you get stuck on the multiple choice, you'll be able to sort of just start plugging the values in for x and see, you know, put in 10, divide by 2, that's 5. 5 minus 2, that's 3. 3 equals 3. You might do it that way. Okay, so it's multiple choice. You'll have the answers, you can check them. And you put, you know, one of the wrong answers, they might have 5 down here. Oh, 5 divided by 2, that's a fraction. Minus 2, I don't really have to do the math. I can just see that it's not going to be 3, right? So you can just do some mental checks as well. All right, so far so good. Any questions? Hear any questions? So we're going to keep on moving. Hide this over here. It's over there. Good. Oops. What's it doing to me? Oh, I better clear the screen. Let's get a new page. And here's some more inequalities. So we're going to be dealing with open circles, closed circles, parentheses, brackets, and all that kind of stuff. And, you know, we're almost halfway through this already, and we still have plenty of time. Okay? And our live stream's still working. Okay. So now we're asked to solve an inequality. Let's see, it's changed. Let's go to blue. So what do we do to solve an inequality? Get the x by itself. Treat it just like it were an equation, an equal sign. So again, the x we want to get by itself. So at some point we're going to divide by -2, but the first thing we want to do is actually subtract 3. Okay, because the story of x is we're multiplying by -2, and then we're subtracting that from 3. So when we solve, we always go backwards from the story. Just like you go to grandma's house, how do you get home? You start at grandma's house and you go backwards, right? So we're going to go backwards. The first thing we do to get x by itself is we're going to subtract 3 from both sides. And again, this inequality is just, it's like an equal sign. We'll just keep it there though. So positive 3 minus 3, 0. We made a 0. -2 comes down, -2x. It's still less than 13 minus 3 gives us 10. Now what do we do next? Divide by close, just the 2. We're going to, because we want to leave the x by itself. So we want to strip the -2 off, so we're actually going to have to divide by -2. That's what's going to give us a 1. If we didn't do it by -2, we'd have a -1 left behind. Does that make sense? Because a negative divided by negative is going to be positive. Okay. Over here, we divide by -2. Now, did the alarm bells just start going off in anybody's head? Did we just do something that's going to cause some problems?
A negative and a positive, right?
Well, there's a bigger problem than that. Let me do this. Let's say that 8, what's the relationship between 8 and 10? Which one's bigger? 10's bigger. What if I divide both sides by -2? 8 divided by -2,
4.
-4. 10 divided by -2. Now which side is bigger? The -4 is actually bigger than -2. It's less negative. Does that make sense? So the inequality has to flip. If that's what dividing by a negative does over here, what do we have to do when we do it over here? We just have to flip the sign. The thing is that because we've got a variable, it doesn't sing to us. Like over here, hopefully we noticed it changed the direction of the number. So what it's going to do, yes, since we divided by a negative, we need to flip that symbol. And I'm going to go up here just to give me more room. We're going to change the direction. 10 divided by -2, -5. -2 divided by -2 is 1. So here we have it. We have x is greater than -5. But we have to remember to flip it. I guarantee you, on the multiple choice, you will also see x less than -5. And if you forget to flip it, you'll think, oh, there's my answer. I must be right. But because we divided by a negative, we have to flip it.
Well, that's when doesn't the negative, when you do that, is positive only when it's
Yeah, well,
multiplied?
yes, over here it made it positive, and the 2's canceled. That's true. But the other thing it did, since we did it to both sides, it actually changed the direction of the inequality.
So if it's negative, has to be the same?
If we divide by the negative. Now just having, now notice up here we subtracted a 3, so that didn't cause any problems. But dividing or multiplying by a negative number,
It stays the
we
same.
have to change the symbol.
But it stays the same signal, so the sign.
Well, a negative divided by a negative will be positive.
So, where did you?
But over here, a positive divided by a negative became negative, if that's what you mean.
Where did you come up with the 8?
This I made up
That was just an example.
because I wanted to, yeah, so this was an example of two numbers that I know. I know 8 is smaller than 10. I could have used 6, and they both can divide evenly by 2.
Okay.
So I just use it as an example.
Oh, okay.
To show us what happens when we divide by a negative number. See, we could see that symbol has to flip the direction of the larger sum. But we don't see that with a variable because it's a variable, right? It's still just an x. So we have to take, and a lot of times with math, that's what we're doing, is we examine the things we can. We examine arithmetic for properties, and then we apply them to things that are abstract.
So I'm a little confused. I see where we're dividing by 2.
Uh-huh,
That cancels the 2 out with an excellent. That's the less than sign.
right.
And -2 into 10 goes 5 times, which is a negative. Okay, -5, and now it's greater than.
It is.
Okay, now I see. I was at. Thank you.
Yeah, and it's because of the process. It wasn't magic, it was just that that's what happens when we divide by negative. It does. So you have to kind of have all this stuff in your background when you're doing math. You have to remember all these sort of processes. But there's really not that many. And with inequalities, that's the one that's different than working with something that's equal. When we have an inequality, that's the one thing that's different. Multiplying or dividing by a negative, you gotta flip the direction of the inequality. So but that's the only thing that's really the only thing that makes chapter 4 different than chapter 3. Well, and then the interval notation thing, but that's kind of, but as far as solving, that's really the only difference. Okay, everything else we do exactly the same. It's just whenever we multiply or divide by a negative, because of what that does, we change the direction of the inequality, and then we're okay. We've accounted for what that does. Okay, so far so good. We'll get the interval notation down here. So there's a couple in here. We'll talk about what those mean. So is it okay if we keep going forward? We okay? Because there'll be some, they'll separate. There'll be ones where they just want you to solve it, and they'll have that inequality. Okay, so let's come to the next one. And how is this one different? We've got an x on both sides. So again, here's the middle part. What should we do? Minus the 2x, because that'll keep the x part positive, right? We could also minus the 5x, but that'll give us negative. So yes, try to keep positive. So if we minus the 2x, it takes it away from the left side, makes it into a 0, and then it gets the x's together on the other side. And we're subtracting, we're not multiplying or dividing by a negative, so we don't have to change the direction of the symbol. So on the left side we have 3 greater than 5x minus 2x, 3x minus 7. Okay. Just like when we had equals, we moved the x's to the right. Now we want to move everything back to the left because we want x by itself. Okay, so what would we do first? Any suggestions? Wanting to get x by itself?
We add 7.
Very good. Very good. We're going to add 7 because it makes it disappear from this side. That's why we do it. Now, I've got some students who don't like writing this. They just let the 7 disappear. I like to write it because I know what made the 7 disappear. So we're going to add 7, and we do it to both sides. 3 plus 7, and again, I'm going to move it up here so we have some more room. 3 plus 7 is 10. The inequality symbol stays the same, still greater than. On this side, the negative 7 went away, so all we have is 3x. Is that good?
I like to show my work too, but sometimes it's a little confusing when you write that in. Do you know what I'm saying? When you subtract or add or divide. So sometimes I'll just write it lighter or put it in parentheses and then carry it down.
Sure, sure. We each develop our own systems, and that's, and some of you, like I said, my one student, she's used to doing it, not having it here, but just putting it over there, and she's consistent using my 121, so that works for her, and I'll tell her to stay with it. If it doesn't work for you, then we'll find whatever works exactly. So then the last step we need to do here is what? Getting x by itself. Divide by 3. Got to get rid of that 3. We're multiplying, so we do the opposite. Divide this by 3. We have to do the other side by 3. Do we have to flip the symbol? No, because it's not a negative 3. Okay. Positive 3s don't change anything. So we keep the symbol the same way. 3 divided by 3 is 1. So there's x. 10 divided by 3 is just, a lot of times they'll just leave it as 10/3. I guess you could write as a mixed number as 3 1/3. Again, I think on one of the questions they did that. Again, for algebra, I really don't like mixed numbers at all. It's just a purist thing of me, because mixed numbers are not very algebraic. So I would prefer to have it this way. Again, an alternate version, 3 1/3, but see, mixed numbers are, again, you might see it like this. You could also turn it to decimal. 3.3333 is what you'd see. So there could be various options, but
So in the test might come either way, so we have to.
right. So just be able to recognize them. That's what and I can't remember. I didn't look that closely, but I remember there was one thing on the test with a mixed number. So that's why I want you to, if you got the right one, just, sometimes they'll change the answer into the different form.
Yeah, but how about if it comes 10/3 and the other one's 1/3?
They won't give you both, no. And they're not going to say which one, no, they'll only give you one or the other. Only one right one. Both of these are really the same number. Okay? 11. Is -2 in the solution set for this bracket -3, 0? So what I'm going to do to show this, and this is something you might want to do, because in the multiple choice, they ask you, like, which one of these is not in the interval, or which ones are in the interval. Which one? Because you're going to choose the one. So you'll have 4 different options. So you have to understand not just whether -2 is in here, but why it is and which ones might not be. So with this interval, I'm going to draw a number line, and the boundary is, we've got a boundary at -3, and one at 0. -3, do we have a closed circle or an open circle? And why?
Close.
It's closed
It's
because
greater than.
it's a greater than or equal to, it's a bracket. Bracket is going to tell us a closed circle. Okay. That means -3 is included in this interval. For the 0, what do we get on that end? Open circle or closed circle?
Open.
Open. That's the other one. Open circle means it's actually not included. So if they asked us which one's not included and we saw 0, 0 is not included in this interval. Okay, it's listed, but it's not included. Where's -2? Right about there. And again, this interval says everything in between is included. So is negative included, or -2? Yes. But they'll be, on the multiple choice, it'll ask like -2, -3, and 0. 0 would be the one that's not included. The other two were included. Okay, so watch carefully whether it's asking for whether it's included or not. Okay. And again, it's just the trickiness. This one, we're just going to do the same. Explain the meaning for the interval notation of this, and I guess the best way to explain it is to draw it as a number line. One boundary is at -1. The other boundary is at 2, +2. -1, do we have an open circle or a closed circle?
Open.
It's open because it's a parentheses. So remember, parentheses will always have open circle. Brackets will have closed. And then it's everything in between is included. That's really what it means. On the test, they don't ask it this way. They ask it just like the other one, and they'll give you some values and say which ones are included or which ones are not included in the interval. Okay. And again, we could also, since we've got it this way, it could be written as -1 less than x less than or equal to 2. So they use the interval notation for compound inequalities, but they don't directly put compound inequalities. I didn't see any compound inequalities on the test itself, but they do use the interval notation, which is a compound inequality.
Okay, so we won't see the greater or equal to sign on there. It's either just going to.
Yeah, you won't be asked to make it into that, but we did cover this.
Okay.
So just helping you to see that there's basically 3 ways we can write it. We can write it with interval notation, we can write it with a graph, or we can write it with an inequality.
Okay, because that's how I had done it.
Right, that's fine.
Could you say that again? Interval notation or graph?
Interval notation, a graph, or inequality. Over here, these are interval notation. I don't have to write it because they got it. Okay. So far, so good? Okay. Again, what I encourage, I've got a few extra copies, 3 or 4. If anyone wants one, they're welcome to take it, practice with it. But also, go through the book and look for similar type problems. Work those similar type problems. You'll be just fine. This is what the test consists of. Similar, but slightly different. Okay. There's one just like this, except it's got different numbers. Okay, but it's the same type of thing. Evaluate the expression. What does it mean to evaluate?
Well, it's not really an expression, is it, with an equal sign? It's an equation.
Well, the equation's over here, and this is telling that x is equal to 5. The expression they want us to evaluate is this part here, which doesn't have it. So good point out. They want us to take 12 over 3x, and what do they want us to do with it?
Replace the x with 5.
Exactly. And I think this is made early in the class. Didn't I tell you about the parentheses? Wherever you see a variable, put a parentheses. What goes in the parentheses, that's what we're evaluating. Okay. So I'm going to highlight it here with, switch to the red color. Just plugging it in, so taking the x is just marking a spot where the number's going to go. And now we follow order of operations. So we have to multiply before we divide. So we take 3 times 5, it's 15, 12 in the top. I guess we could have done something else, but, and then we can reduce this, can't we?
Yes.
Yeah, 3 goes into both of them. Guess we could have just canceled out the 3 and actually could have done it up here, but 3 goes into both. So 3 goes into 12 4 times, 3 goes into 15 5 times, so it'll reduce down to 4/5. And that would be the answer you would probably see. This is a reduced answer. Okay, so far so good. This one is actually it. We got another evaluate. What does that mean? Take the number they give us for x, plug it in for the x's. Okay, so what I'm going to do is right below the x's, I'm going to rewrite this with the parentheses, cubed, minus 2, parentheses, squared, plus 1. So I've just rewritten the expression and I've replaced the x's with parentheses. And why did I do that? Because it's easier to plug something in for a parentheses than it is for an x, because x is kind of like right there in the way. So what we're going to plug in there is -2. And you could use your calculator on this if you want, or use your math facts. -2 to the third is -2 times -2 times -2. Should be -8, right? Because there's 3 negatives in there, so 2 of them make a positive one. So this should come out as a -8. This is going to be -2 squared. -2 times -2, positive 4. So instead of doing 2 steps at once, I'm going to leave this. I just got a positive 4 here, and plus the 1. And then I take the positive 4 times a -2. What's that going to give me? So it's at -8, and then -2 times positive 4 is another -8 plus 1. What's -8 minus 8?
0.
Careful.
Oh.
I was hoping it was.
-16.
It's yeah, so they're both negative. You're getting more negative. It's actually, when the signs are the same, you add them. So that's a 16, a -16. I'll go ahead and write that. So we do one step at a time. But it is very tempting to look at that and say that's 0. And that would be one of the multiple choice wrong answers. We'd see the answer of 1, and you think that's what. So then we got -16 plus 1. Now these are opposite signs, so we subtract. 16 minus 1 is 15.
But is it, it's negative because 16
It's
is
negative
greater.
because 16 is a bigger number, and so it's more negative, yes. So that's the way I think through addition, subtraction problems, looking at whether they're the same sign or not. And again, when you have the evaluate, your answer is going to be a number. Okay, you doing okay? Wonderful way to spend the Valentine's, right? You know, can't always get the holidays on the dates you want them on. Okay, so President's Day, you know, isn't Valentine's Day like more important than President's Day? I don't know.
It's Arizona Statehood Day as well.
Oh, it is. So yeah, there's
Yeah,
double
today
the.
is Arizona.
So the day of Arizona. Interesting. And okay, so this one, divide and simplify. So let's go. I was using blue, so let's switch to a green. So remember these ones. Basically, think of this as a distribution problem. We're distributing the division. So the first thing we want to do is break this up into 2 fractions. So we're going to write as 6x divided by 3 minus, taking the minus from the 12 part here, 12 divided by 3. So we distribute the division. And then we reduce 6 divided by 3. 6 goes into, or 3 goes into 6 2 times. So we're going to be left with 2x. We still got the minus. 12 divided by 3. It's 4.
Yeah.
And there we are. We simplified it as far as we could take it, 2x minus 4. But you'll get one like this where you just have to distribute the division. Break it into 2 fractions, reduce it. How's that? Questions? This is what, page 3? I'm gonna clear this. It won't disappear, but I've saved it also. So in the notes, you'll see both the video and you'll see screenshots of the completed pages as well, because sometimes those are easier to go back to. Okay. Oops. So we're on 16 now, 16, 17, 18, the simple interest, and then we'll have one last page. And we'll be good to go. And again, remember, this is all recorded so that you can watch it again later. You can fast forward through the boring parts and my advice about life and stuff, because who needs that? You know, you probably got enough of your own advice, right? Let's see. Oh, let's stick with our Greek. So this one is to simplify. What does it mean to simplify? Notice what is not here. How do we know this is not a solve? There's no equal sign. You cannot solve if there's not an equal sign. So good, there's just not a solve. It's just kind of, it's basically distributing and combining like terms. Okay. We're not going to end up with a number. Most likely we will not end up with a number as our answer. It could be possible, but so we're going to distribute, and we take the 2 and distribute here and here. And then what we're going to do with the second one, notice we've got a -5 that will distribute to each of the second parts. Okay, so we'll take it step by step. What's 2 times 12x?
24.
Good. Get a 24x. And then 2 times -4? -8. The second part, we're taking -5 times 6x. That gives us like -30x. Okay. And then -5 times -8, a +40. Okay, so that was the first step. Get everything out of the parentheses by distributing. And then the second step is to combine like terms. So where's the like terms?
24x and 30x.
Yeah, those two are like terms. 24 is positive, 30 is negative. So since they have separate different signs, what do we do? What's the operation? Addition or subtraction? Thank you. I was going to mess it up. That's why I was paused, because it is subtraction. They're different signs. So all you have to think is 30 take away 24 is 6. But is it positive or is it negative?
Negative.
Negative, because 30 is larger and it was the negative. We were more negative, so it's going to maintain its negativity. Still a grumpy old man. Okay, can't change those guys. Then the other like terms, the numbers that are by themselves. So then let's go ahead and switch color here. We've got a -8 and a +40. Again, opposite signs, so we are going to subtract. So just think it's going to be 40 minus 8, 32. Is it going to be positive or negative, though? In this case, it'll be positive because the 40 is positive, so we're more positive than negative, so positivity can win out as well. 32. Are we done? How do we know we're done? No more like terms, right? We've got a thing with an x, so there's no more like term. That's the key, because I'll see students keep going. They'll take this -6 and combine it with a 32, but that's not legal. It's against the law. Combining unlike terms. Okay, so there we are. That's it. But sometimes you'll see them do those things in the wrong answers because they know some people are tempted. In fact, you know, this I love this math department, but we got real tricky one year. We gave this was with our college algebra. We gave one set of students an open-ended test like this, and the next year we made the multiple choice test, but we took the students' wrong answers from the previous years because we figured those were really good wrong answers because the students came up with them. The teachers always come up with bad wrong answers because we know what the right thing is to do, but students come up with the best wrong answers. And that made that test so hard because the wrong answers were so good. You know, but that was kind of tricky of them. It was before I got here, so I say that, you know, guys, you guys were sneaky, you know. You had the students come up with all the wrong answers, and then they put that on the next test. And, you know, okay, smart, yeah. But it was with all the intentions of helping students learn math. So that's okay. Here's another simplify, right? We're not solving. So get that, the difference. We only solve when they say solve. There's the evaluate is not to solve either. Evaluate's to plug in and simplify. And that one will get a number. This one's, we're not even evaluating, but it's just to simplify, which means we'll still probably have an X left. Usually it means there's going to be one thing that does get distributed, and we'll do that here because of the parentheses.
Right.
The first few things, nothing's going to happen to them. So the X comes down, the -1 comes down. This 2 is going to distribute. 2 times X is a positive 2X because 2 times 1 is 2. 2 times -3, -6. Just be careful. One of the errors I make when I do algebra is I sometimes add when I should have multiplied. I take this 2 and the 3 and I might write it as 5. But I'm multiplying, but I sometimes just get in a hurry. And then where are the like terms?
The 2 X's.
Yeah.
The X and the 2X.
We got an X and a 2X. And remember, that's a 1X and a 2X. We're adding them because the signs are the same, right?
Right.
That's going to give us a 3X. And then the other 2 is a -1 and a -6. They're both negative. We add them, we're going to get 7. And 6 is bigger, so it stays negative. Again, they're both negative, but 6 and 1, so we got a -1 and a -6. So both are negative, we add them. And the answer is going to be negative. It's like we took a loan twice. We borrowed $6 and borrowed $1. We owe them $7. But it's one of those tricky ones that can get us. And that's it. There are no more like terms. We are done. This is going to be the answer. How we doing? Doing okay, yeah. I'll watch the video later, right? Okay. Simple interest. We've got this formula. I'm going to rewrite the formula down here because that's what we're going to be using. And then below that, I've looked a little bit ahead. You might not notice this, but A is accrued value, so they're telling us what each one is. The question is going to be, if your savings bond has an accrued value of $20,000 after 30 years of growth at 10% interest, then what was the starting principal? So you have to look, what are they asking about? They're asking for the starting principal. They want to know what P is. So what they've done is they've given us numbers for everything else. So they've given us A. We're looking for P. We're looking for this P. But they gave us R, and they gave us T. And this is a tricky one because they're asking for the hardest thing to get, but we can do it. So what I did is the equation that they gave us, is just a template of where everything's going to go. And the reason I write right below it is so now I know I've got an open space, but I know what goes where. Otherwise, I'll forget, right? So now we come back and they give us some information. If your savings bond has an accrued value, that's what the A is. A is the accrued value, 20,000. So where did I put that 20,000?
Under A.
Under the A, in this nice little place that I made a nice big open spot for. So that goes in there. And you'll see that the parentheses will just come off, but I wanted to put it that I'm plugging it in. P's, I'm not going to plug anything in because that's what I'm looking for. Did they give me an interest rate? 10%. How do I write that as a number to turn it in? So again, if you need to 10%, you divide it by 100, and that has the result of moving the decimal over 2 places. So 0.1, 0.1 or 0.10, however you want to write it. Since I don't have a lot of space, I'm just going to put a 0.1. And then time, they told us 30 years, right? T is in years. So I could put the 30 in there. Now I'm set. I know how to solve these things, I think. So this side, the 20,000, is there any need for these parentheses? Nothing in front, no. So we could just rewrite it as 20,000. That's 2,000, 20,000. You got more money. Is that 20,000?
Yes.
Sometimes you put so many zeros, it's hard to tell. So this is P. And then what can I do with this 0.1 and the 30? We can times them. 30 times 0.1. Where's our calculator? I know you won't believe me if I just tell you. $30 times 0.1. Yes, it's just 3. Moves the decimal over 1 place. Okay. And the way I'm going to write that is P, instead of P3, it's 3 times P. Does that make sense? I mean, it's P3, P times 3, but when we've got a variable, we usually put the number in front to make it a coefficient. Okay, so that's the tricky part of it. Well, I got 2 different P's, but what can I do with P? We can combine them. They're like terms. This is 1P. This is 3P. Didn't we start off with something like this? With the price and the 1% and the, or 100% plus the, it's coming, the tax.
Mm-hmm.
This is really very similar. So what we get is we get 4P, 1 plus 3, equals 20,000. And then we just want to solve for P, don't we? What do we do to solve for P? We're going to divide. I'm going to go for some different colors just to break it up a little bit. So we're going to divide by 4 because we want P by itself. Divide by 4. So we end up that P ended up equaling, is that like 50,000? Because 4 goes into 25 times. And then there's still, no, it's only 5,000.
5,000.
I was thinking I was richer than I was. Okay. That's why I keep hoping that, like on my paycheck, they just add on an extra 0 on the end. Do that sometime. On the other side of the decimal point, not on the, not on the back side. That wouldn't help. But put the 0 in the right place, just once. Be nice. Get my bills paid off. But they'll probably come back the next day and ask for it after I've already spent it, right? Okay. So.
But if they did that legally, you have the option to make a payment plan because it wasn't a mistake.
Yeah, but
I'm just.
ask. I won't get into politics, but it's been done, and they take it before they have you sign a contract that if they make a mistake, they have the right to take it back.
Oh,
And so it's like, unless you so just take all your money and run. Just don't come back to work the next day. Just get out of there. No, they're not going to do it.
Would miss you.
Yeah, no. The thing is, $30,000 sounds like a lot, but it's gone pretty quick. Even 100,000, even $1 million sounds. I used to be in the financial planning. I had a client who they won the lottery. They won like $750,000, and this was 30 years ago when $750,000 was like millions of dollars. They were actually my boss's clients, so by the time I got to them, they were down to like $250,000. Within 5 years, they were down to like $25,000. It was just, it's just amazing how fast. You think you pay it all off, but then they got toys and did this and that, and and they weren't working. They were living off of it, and so after that, they said, "Oh, we got to go back to work," because they were young folk. They were in their 40s. I mean, that doesn't sound young, but it is. Got a lot of life to live. So, anyway, so far so good.
Yep.
That's it.
5,000 is the answer.
That is the answer. So and this was the harder one to do. On the test I can't remember, but sometimes the test they'll give you the principal, and all you got to do is find the accumulated value. That's a little bit easier, but this is the harder one. Okay, so we're going to save this one. So again, another screenshot, and then we'll we got the last page to just kind of keep on going on. A few more problems, not too much, and then it'll be recorded for us. Still going, and again, I'm working off of the Wi-Fi, so hopefully it's all going through. If not, I'll do this on again without all the jokes in it. I'll just kind of work it through if I need to, but hopefully it works out. Because the good part of this is you guys asking questions. I could just explain it and it sounds all good, but when you're watching the video, you have questions and you like say, "Hey, can you do that this way?" This is your chance. Okay, so these are a couple of word problems we're going to take a look at, and let's go with red. So first, I'm going to just start highlighting numbers. We got 200 sodas to sell at the carnival. So you just pick up numbers as you go. We got $50, 75 cents. Okay, I see a letter. Usually I like to put letters because in math that's going to be our variables. So we got P for profit, okay? We got an N. That's standing for number of sodas. So, I'm not trying to read this, but I'm just trying to look for math stuff. And then I come to the end. I'm trying to see, what are they asking? Oh, they want us to write an equation. There's not really a question. So they want us to write an equation that models the profit. They don't want us to solve anything. They just want the equation. Okay? We want P for profit based on the number of sodas. Okay? That you sell. And then they give us this thing. Remember, your profit is the amount of revenue you take in minus the cost of buying the product you have to sell. So that's a very important thing. What's our revenue? Well, you plan on selling them for 75 cents each. 75 cents, right?
Right.
You can go 0.75. And how many sodas are we going to sell?
200.
Well, hopefully we sell all 200, but we don't know, so we call that N. But that's good, is think of a number. I would just multiply, if I sold them all, I'd multiply by 200, but I'm not sure that I'm going to get to sell them all, so I'll put my N. Okay, that's where that goes. So that's a positive thing. That's money coming into me. Where's my costs? $50. I paid for it already. There's no variable part. I paid my $50. It's been paid minus the 50. And that's going to be my profit. That's all there is to this one. Yeah, no variable cost or anything. It's just $50. Take that away, 0.75 per can that I sell. And yeah, if I sell 200, I'll be off. I'll be doing pretty good, right? I think. So 100 would be 75. So it's $150. Take away 50. I made $100. Not bad. Met some nice people at the carnival. Maybe had some fun. Maybe they got some free rides too. Who knows?
Cotton candy.
Cotton candy. Big chunk of turkey leg or something, whatever they got going. All that kind of fun stuff. Face paint. Okay. For the previous problem, how many, now they want us to do something with this, right? Yeah. That's no free lunch here. How many sodas must you sell in order to break even? Remember we talked about this break even. What does it mean to break even?
You don't make a profit, but then you cover your costs.
Yes, so you have a profit of zero, right? $0. You didn't make anything, you didn't lose anything. So basically we just we take this thing that we started with, and what we're going to do is we're going to put in 0 for p, take our equation, and solve it for when do we cover our expenses. And again, some people, you'll look at this, I'll just take 50 divided by 0.75, and you're right, that's how we would do it. But in doing algebra, we do kind of go through the steps. We just solve this equation. We add 50 to both sides, that's the $50. Over on this side, it became 0. 0.75 in. Now, how do we get the n by itself? Exactly. We're going to divide by 0.75 because that makes a 1n, right? These cancel. So what I do to one side, I do to the other. And I'll write my final answer. What's 50 divided by 0.75? What's that?
It's like 66 point something, but I did 67 because 66, it's 66 point,
6666.
yeah.
Yeah.
And I'm like, you can't sell 60.67, so I rounded it to 67, so that.
Yeah, you don't sell part of a can.
Yeah.
Say, here you go, here's your 2/3 of a can soda. I broke even now.
So it rounded up to 67.
So round it up to 67 would be the best. Yes.
Now, could you do the 67 in less than?
Let's
Or
see,
equal
remember
to 50?
how many sodas must you sell in order to break even? Well, this one is just how many to break even, so you have to sell 67 to break even. If you said what you could do, if I sold greater than 67, then that's profit. Less than 67, and
I just didn't know if they wanted, because it says revenue is equal to, and I wasn't sure if they wanted greater than, less than, or greater equal to.
No, it's where, I mean, would they give you this, you could also just say, okay, revenue equals cost, so it'd be 0.75 n equals 50. You could kind of jump to this last statement if you wanted to. But no, they didn't want an inequality, they wanted just a single answer. How many cans do you need to sell to break even? And again, because it's a partial, we round it up, and we're good. One simplify, one evaluate, and again, these are very similar to the types that are in the test. Again, the numbers are a little bit different, but if you could do these ones, that's basically the process. That's what we're looking at, do you get the process down? So in simplifying, what are we doing? It's another word for simplify. Combine like terms, right? So we got an x to the third and 3x to the third, so we can combine those.
That's 4x to the third.
Right, because it's 1x to the third plus 1 plus 3. And then there's this x squared and an x squared, so a plus 2 and a minus 1. So we're going to subtract because they're opposite signs. 2 minus 1 is
1x
1x squared, and it's positive because 2 is bigger than 1. What else is left? Then we got an x.
and 5x.
There's a 3x and a 5x. They're both positive.
8x.
Add them together. And what about that negative 2?
-2.
Can't combine it with anything, so it just comes along for the ride. And that's as simplified as we can make it.
So you do put the plus and the minus signs in there, or would you
Yes.
put commas?
Plus and minus.
Okay, use
Yes.
those, okay.
For these, when we simplify plus and minus.
Do you mind repeating that again, Mr. Littlecroft?
Yes, so when we're combining like terms, we have to separate them with a plus or a minus, depending upon their value.
But I meant the whole thing, because I was trying to think it through as you were saying it, but I didn't watch the video.
Okay, yeah, so it's 4x cubed plus 1x squared plus 8x minus 2.
Okay.
So yeah, combine the like terms, the x to the thirds, so it's 3 plus 1 is 4.
Okay.
The x squared, 2 minus 1 is a positive 1. And then when we got to the x's, there's a positive 3x and a positive 5x. So 3 plus 5 gives us the 8x. And negative 2 is just negative 2. All right. Almost there. So we're going to evaluate this expression. And again, I'm going to just rewrite it with parentheses. So 3xy, I'm going to write it 3 parentheses, parentheses. And I'm right below here, so I know the x is the first one, the y is the second one. 2, and then replace the x with the parentheses and the y with the parentheses, but the y is squared. Okay, what do I put in for x?
2.
2, so this x is the first one, so I put a 2 in there, and this x goes there, so the 2 goes in there. What do I put in for y?
Negative 3.
Negative 3, so we'll change to a green, showing that it's going to be different. Put a negative 3 here and a negative 3 here. And now it's all numbers. It's just order of operations. So we'll take care of the multiplication part first. This first part, I take 3 times 2 is 6. 6 times 3 negative 18. Because we had a positive 6 times a negative 3. That's going to be negative, and 6 times 3 is 18. So the first part was all multiplication. Second part, and now it's a subtraction here, but I'm also going to carry the, well actually, what do we have to do on the second part first?
The exponent?
The exponent, thank you. So we got this, we got negative 3 squared. It's negative 3 times negative 3.
Negative 9.
Positive 9.
Oh.
Be careful. Positive 9, because a negative times a negative is positive. Positive 9. 9 times 2, 18. 18 times negative 2 is 36. So we get a negative 36. Okay. And again, you could also put this in your calculator, and your calculator will probably just handle it just fine as you put it. We've got 2 negatives, so what are we going to do with these 2 numbers? If we were multiplying, it would be positive, but we're going to add them and then take the sign of the larger number. So 18 plus 36, we add those, that's 40, that's 54. I think if I did it right. Again, we're going to use a calculator. And since 36 is a larger number, it's negative, and actually they're both negative, it's going to stay negative. We went further in the hole. Okay, negative 54. So that would be our final answer. But be careful, they will make that mistake. One of the wrong answers will probably take negative 3 squared and leave it as negative 3, and then this becomes a plus, and you know, you're just one sign off. That was always what got me in math. It's worse to just be off by a sign because they anticipate that and they put the answers. It's sometimes if you make bigger mistakes, that's okay because they don't make that as one of the wrong answers. Okay, so we're going to take a picture. This is page 5, and then we're going to clear it. Yeah, and then we'll clear it off with a new page, and we got just 2 more to do, and then we'll just wrap it up. And believe it or not, it sounds like it stopped raining, doesn't it? Mm-hmm. Which is it's our Valentine's gift. Okay, don't have to go in the rain, hopefully. Okay, so we'll see if we can finish it up. So again, I got a word problem, so I'm just going to start underlining some numbers. And as I do it, $4 for adults, $2 for children. Then I look for my letters, which I made nice and big and bold. So I've got a T, an A, and a C. And C for children, A for adults, T for total. That makes sense. So, okay, now I start reading. To go to the carnival, the price of admissions is $4 for adults, $2 for children. Write an expression, not an equation, just an expression, so no equal sign, that represents the total revenue taken in by the carnival. So T for adult, or T for total. Well, They actually want an equation because they want to know a total, right?
Yeah.
So it's,
Yes.
this is a bad use of the word expression. They should have said write an equation. So let's do this, just to show the world that we know what we're talking about. This is not an expression, it's an equation that they're asking for. We're going to be asked to write an equation. Bad math grammar there. Probably bad math spelling too. Equation, is that right? Doesn't look right for some reason, but it's okay. So we're going to say that the total is equal to what? Well, each adult is going to pay. So if we had 10 adults, how would we calculate how much money we got from the adults? 4 times 10, the $40. So, but we just made up the 10, right?
Yes.
So
It's
it's
actually 4A.
4A. Exactly. See how that works though? We know what to do. It's got to be multiplication. And then what we do for the children?
To C.
2C.
Which you're gonna add them together.
Okay, and to get the total, we add them because we wouldn't multiply them. So we get the cost for the children, the cost for the adults, and then we add those two together. And that's all there is to it.
So would you always put the T equals 4A plus 2C, or can you do the 4A plus 2C equals T?
Sure.
That's how I
That's
did
the
it.
nice thing with equal signs is you can go either way.
Okay, I just wanted to make sure that it was still okay.
And again, it's going to be multiple choice, so they will get the answer. They will decide how it's going to look. You just have to choose the right one. And they wouldn't choose,
Okay.
yeah. Okay, so that's good. And this will come in later on. We do these kind of problems. We'll actually solve these for maximizing stuff.
That's what you do with the next one. The second
Oh,
part,
yeah.
the
For
second
the previous
part.
problem, if the carnival took in $400 and there were 20 adults attending, then how many children came in as well? So again, we take our equation, and again, whichever version you want, I'm just going to rewrite it so that
T
it's.
equals 400.
So T is 400, so I can put the 400 under the T. We've got 20 adults, so that's going to be 4 times 20 plus 2C. Now I've just got one unknown. I can solve for C, and I'll be able to know how many children are there. So 400, 4 times 20,
80
$80.
plus 320.
So you subtract the 80. $40 minus 80 is 320. Remember, 80 minus 80 becomes 0, so it disappears. 2C comes down, and what do? Divide by 2. That's a lot of kids. There was, what was that, 150, 160,
160.
160. So 20 adults were watching over 160 kids. That's, yeah.
Not good.
Hopefully they brought some Tylenol with them. Other kids were having fun, yeah.
They were all 4 or 5-year-olds.
Yeah.
20.
Great carnival. 20 adults. So that's, but you got it. This is what we're looking at. And again, we'll do this 2 more times. We'll do like 3 more units and tests and such. But this will be a
kids per adult.
there. Oh yeah, good calculations. So this is it's live streamed, so it's available now. I will also put the link into Canvas, so you can watch it as much as you want. No class on Monday because of the holiday. Wednesday we'll just jump in and you'll get another one like this. It's also yellow, so I did that to kind of connect. We'll see if it works. But it'll be multiple choice. Okay, multiple choice. You got it. Anyone want some extras? I have nothing to do with them, so they're gonna, let me stop. Let's see. Where are we? See you guys. Thanks for attending.